this lesson, we are going to talk about some of the things that you learned at the very end of last year. This was while we were in remote learning last spring, so I really want to make sure that I go over it with you to make sure that you understand it and are able to use this information. We're going to talk about how we prove that shapes are congruent, especially triangles. That's our main focus. And we're going to talk about the expectations for doing two-column proofs. So a little bit of vocabulary first. Two shapes, two figures are congruent if they are geometrically equivalent. They have to have all of their corresponding angles match up and have the same measurement, and all of their corresponding sides need to match up and have the same measurements. So if we had two shapes such as you see here on the board, two quadrilaterals, we'd first have to figure out which angles match up. And to do that, we might want to spin them or flip them. So let's see what happens if I spin this one around. That looks pretty close. Wonder if I move it over here and try to line them up and spin it just a little bit back and move it just a little bit. Okay, it looks to me like those pretty much are congruent shapes. So let me move this back over here. What we see when we've done this is that angle L matched up and had the same measurement as angle M. Angle M and angle Z, actually that was L and W and M and Z, and N and Y and X and O. So all four sets of angles matched up, and we saw that the sides all matched up and were congruent. So this one was the same length, these two were the same lengths, these three were corresponding sides, they were the same length, and these four also had the same length. So technically, to prove that two shapes are congruent, you have to look at however many angles there are, make sure those all have the same measures, and how many sets of sides there are, and make sure that those all have the same measurements. Since we're mostly focusing on triangles, I'm going to be able to give you some shortcuts or review the shortcuts that we showed you last spring. Another vocabulary word, because most of these shortcuts will be called postulates. That just means we're not going to bother with proving it. We're just going to accept that it's true. One other relationship that we talked about a little bit last spring was if you have two triangles, and if you can figure out that you have two sets of sides that match up, you automatically know that the third set would also match up and be congruent. So here's a picture of how that might work. So if I had these two triangles, if I knew that angle A and D were the same, and if I knew that angle B and E were the same, then C and F would also have to automatically be the same. The reason for that is A plus B plus C has to be 180 degrees. Also, D plus E plus F has to be 180. But if A and D are really the same, I could simply substitute an A right there. If B and E are the same, I could substitute a B right there. So what I get from my first one is that C equals 180 minus whatever A and B are together. And from this one, I get that F is 180 minus whatever A plus B is. So if C and F both equal this same number, C and F have to also match up. And the reason for that is AA, if you know two sets of angles, and then not an equal sign, but an arrow, because that implies that all three sets of angles have to match up and be congruent. So let's start to talk about triangles. If two triangles are congruent, then that means by definition that all three sets of the corresponding angles match up and are congruent, and all three sets of corresponding sides match up and are congruent. So technically, by definition, we would have to prove 6 things. We would have to prove 3 sets of angles and 3 sets of sides, and that is a lot to have to put in a proof. So what we learned last year, we had a bunch of letters for things that were some shortcuts where we only have to show about 3 things to be able to say that the triangles are congruent. One of those was the SSS congruency postulate. What that says is if I know these 2 angles correspond and have the same measure, if I know these 2 angles correspond and have the same measure, and if these 2 angles also have equal measures, that is enough to say the triangles are congruent. We don't have to prove that the sides match up and are congruent. Another one that we saw last year was SAS. What that one says is if we know one set of sides is congruent and a second set of sides is congruent, and then this part is important. The angle is between those 2 sides. A is between the 2 S's. So we would have to know this angle right here. If we know those 3 things match up, that is enough to say that the triangles are congruent, and our reason would be SAS. The next one is going to have 4 letters in it. AAAS, triangle congruency. So this one we actually have to have 4 things. It is not enough just to say these angles are congruent, these angles are congruent, and these angles are congruent. Those are similar. They are not the same size. If we want to be able to say that they are congruent triangles, we have to know all 3 sets of angles, that those corresponding angles are all congruent, and then we also have to know any one of the sides. Then we can say that the triangles are congruent. We don't have to know that the other 2 sets of sides match up. The last one that we shared with you last spring was HL, triangle congruency. H stands for hypotenuse. Now it looks like maybe we only have to prove 2 things here, but you only have a hypotenuse if it is a right triangle. So you must have in your proof that you have 2 right triangles, and you need to say that the 2 hypotenuses match and one other set of sides or legs. So we would have to prove that these are both right triangles. Our proof would have to say that the 2 hypotenuses are congruent and one or the other set of legs match up. If we have those 3 things, we don't have to know that the other 2 sets of angles match up, and we don't have to know that the other side also matches up. Okay, there are some other properties that we are going to use this year that we didn't really stress last year, and these are some ways that we can prove that some things are equal to each other. Transitive property, I feel a little bit like Dr. Seuss here. If A is the same as B and B is the same as C, then A and C are the same as each other. If thing 1 is the same as thing 2 and thing 2 is the same as thing 3, then the first and the third one are also alike. In other words, they're all alike. Reflexive property we did use a little bit, and that was to say that one thing is the same as itself. and we'll do this a lot with one side has the same length as another side, we can do each of these with either equals or congruent. Equal is when we are actually talking about numbers or measures, and congruent is when we are talking about shapes. So we did a lot that the hypotenuse was congruent to itself when two different triangles shared the same hypotenuse. Symmetric property just means we can turn it either way. A equals B, B equals A, does not really matter which one comes first. Those are equivalent. And then the other part of a kind of an alphabet soup that we gave you last spring, CPCTC, says corresponding parts of congruent triangles are congruent. So before you can have parts of congruent triangles, you first have to prove congruent triangles. So somewhere in your proof, you have to say that the triangles are congruent. So maybe you used three things out of SAS. So maybe you had three sets of things that you showed in your proof had to be congruent. So you showed three things. That was enough to say that the triangles are congruent. And then you had three things left over. So by CPCTC, you could say any one of those other three sets that you had not already talked about in your proof, that means that set has to be congruent. Okay, let's try a few examples here. So part A of example 1, this just says to give the congruency postulate for showing that these are congruent. Now what I want to see is I want you to mark on the sketches, so you'll need to copy the sketch if it isn't already there so that you can mark on it and then say which postulate. So let's see what we know. TV, so that goes from here to here. That is congruent to WV, so that's this one. And UV, that goes here to here, is congruent to XV, and that goes from here to here. Uh-oh, I've only got two things. I need three at least for these postulates to work, so I need to look at my picture and see one more that I could have in there. Oh, I have vertical angles right here, so I can say these two angles are congruent. Now when I look at what I have marked on my picture, I have two sets of sides and one set of angles. The angle is between those sides, so I can say SAS congruency postulate is the reason that these two triangles are congruent. I could write my congruency statement as triangle, and order matters here. First triangle, any order you want. T, V, U, and it needs to be congruent to the other triangle. But now I need to put down whichever angle corresponds to T. T was across from the double tick marks, and across from the double tick marks here is W. V was the vertical angle, and so that's still going to be the vertical angle there. And let's just make sure U is across from one tick mark. X is also across from one tick mark, so those are also corresponding angles. If the problem does not already give you the congruency statement, I would like for you to write that in on your problem sets. If they already say what can be used to prove this, you do not have to rewrite this congruency statement. Part B of example 1, same directions. We're going to copy the picture. We are going to label the parts that they give us that are congruent. For this one, we know that angle H and angle L are congruent. We know that side HJ is congruent to side JL. Technically, that should have been LJ so that we keep things in corresponding order. We need to somehow come up with enough to be able to say that these are also congruent. So we begin to look at that, and we see that again we have vertical angles. Put my reason down there. And I did not have ASA in my list. I need that other set of angles. So I am going to say that since I have two sets of congruent angles, the red ones and the blue ones, that means that the third set must be congruent, because if I have two sets that match up, the third set must also match up. AA implies AAA. Now I have all three sets of angles are congruent and one set of congruent sides. So I can say that these are congruent by angle, 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 side. And I could write my congruency statement as triangle HIJ for the left is congruent to. H was marked in red, so L is the corresponding one. I is marked in green, K is marked in green, so they are corresponding angles. And then the two at J are both marked in blue, so they are also corresponding angles. One more of these, and then we'll actually do our first proof for this semester. So example 1, part C, same directions. And so let's see. Oh, I've got a right triangle in there. So is this going to be HL with a right triangle? Well, let's see. We've got to look at what else they give us. HI is congruent to JK. So that's a leg. But then they say IJ and KL. They did not tell me the hypotenuse. There's no such thing as side, side implies side, side, side. So I need to look at this again. I've got two sets of sides and I've got right triangles, but those 90-degree angles are congruent. So actually I have two sets of sides and the angle in between them. So I can use SAS, that angle is in between. If I write my congruency statement, triangle HIJ is congruent to triangle, and now I need to be careful. H is across from two tick marks. J is across from two tick marks. I is the right angle. K is the right angle. J is across from one tick mark, and L is across from one tick mark. So there is my congruency statement for this particular set of triangles. And then let's do a two-column proof. For two-column proofs, you need to copy the picture, not real big. You need to leave enough room for the proof. You don't have to write the things that you are given, but you will have to label those on the picture. You'll have to label other things on the picture as you show them in your proof. For your proof, you need two columns. One, you write out the word statements at the top. The other, you write out reasons at the top. We are going to number these so we can tell which equation, which statement goes with which reason. So I am going to begin by labeling on my picture, AB is congruent to CB, and I need to write those given statements in my proof. So AB is congruent to CB, line over it because it's a line segment, and my reason is given. I want the numbers on both sides because sometimes your columns get where they aren't really matched up real nicely, and it will make it much easier for me to see and grade if you put the numbers in both columns, not just the left one. Let's also label on our picture angle ABD. So if I start at A and go to B and then to D, that will be this angle right here. And CBD will be this angle here. I need to put that in my proof. Everything that you are given needs to go in your proof. And then we need to start thinking about, well, what else can we come up with on this picture? Well, it looks to me like my two triangles both have side BD as one of their sides. So I am going to say that BD is congruent to itself. And I'm writing those in order. D is going to end up looking like a right angle here to me. So I want to make sure that the D's match up on that one. And I'm going to just put a circle on top of that one to help me see that I'm actually using it both. I'll use circles a lot of times whenever I'm talking about the reflexive property, that something is the very same as itself. Okay, do I have enough now to have congruent triangles? I'm trying to get to parts. So I need to have congruent triangles first. Then I can try to have congruent parts. So I have two sets of sides and an angle, and the angle is in between. So I'm going to be able to use SAS congruency. But I need to get my statement written in the correct order. So the first one, the order doesn't matter, so I'll just say triangle ABD. That needs to be congruent too. Okay, A is across from the one that I marked in blue, the reflexive side. C is also across from that. So wherever I have A in this statement, I need to have C on the other side. Okay, B is the one that I marked with one green tick mark on the left, and it's also B on the right, so those are corresponding angles, and that leaves D for the third letter. Now, I am trying to show that AD is congruent to CD. If I look at my congruency statement, A and D are the first and last letters. C and D are the first and last letters for my corresponding parts. Since that matched up, AD does correspond to CD. Those are both across from the angle that I marked with one tick mark on there. So I can say AD and CD are congruent parts. And my reason is that the corresponding parts of congruent triangles are also congruent. And that finishes our proof and our lesson for today.